All right. Part of the section on functions is about domains. So it's important that you know how to determine the domain of a function. And for some functions, it's a very easy thing to do. If I told you that f of x equals x squared, and I said, what's the domain? Well, the domain is the valid values of x being the input parameter to your function. And so what you want to look for, are there any restrictions? So in the case of f of x equals x squared, are there any restrictions on what x can be? In this case, the answer is no. I can make x be any negative number I want. I can make it 0. I can make it a positive number. And I can put it through this function. There are no restrictions. So what you would say, the domain is comprised of all real numbers. Okay, if I gave you 3x, f of x equals 3x minus 1. Same thing. Is there any restriction on the x value that goes into this function? And in this case, the answer is no. There is no restriction. X can be negative, 0, or positive. So once again, you would say all reals. But there's two conditions that you need to look at where restrictions come into play. Okay, the first of those is division by 0. Okay, cannot divide by 0. And the second is where you have even roots. All right, let me talk about each of those. Division by 0. If I said f of x equals 1 over x minus 3, I said, what's the domain? Well, what value of x creates a 0 denominator? Well, in this case, if x were to be 3, I would have 3 minus 3 in the denominator. 3 minus 3 is 0. So x cannot be 3. So you would say that your domain is all reals except where x equals 3. Okay? If I gave you f of x equals 3 over x squared plus 5x plus 6, and I said, what's the domain? Well, once again, the denominator cannot be 0. So you can set the denominator equal to 0 and solve. And that would basically give you the values of x that are not permissible. If we recall from Algebra 1, the way we do this is we factor, and then we set each parenthesis equal to 0. So x is not allowed to be negative 3, and x is not allowed to be negative 2. So in this case, our answer would be all reals except where x equals negative 3 and x equals negative 2. So division by 0, you got to be on the lookout for. The other one you have to be on the lookout for are even roots. What do I mean by even root? That's an even root. That's an even root. That's an even root. And that's an even root, and it keeps going. Now remember, I can rewrite roots as exponents. That's x to the 1/2, x to the 1/4, x to the 1/6, and x to the 1/8. And the rule is, for any function like this, the domain is all reals where x is greater than or equal to 0. Because if x were negative, if I had the square root of a negative 4, there's no domain. You can't have the square root of a negative number. Can't have the 4th root of a negative number. Can't have the 6th root or the 8th root of any even root. You cannot have a negative number under here. Likewise, you can't have negative numbers here. So all 8 of these, if I said f of x equals the square root of x, the domain would be all reals where x is greater than or equal to 0. Now we can make it tricky. I could say f of x equals the square root of x minus 6. I could say, what's the domain? Well, again, the quantity under the radical cannot be less than 0. So the value of x equals 6 is what creates 0 under the radical. 6 minus 6 is 0. So 6 is okay. But if you were to put 5 in for x, 5 minus 6 is negative 1. That's illegal. 4 minus 6 is negative 2. That's illegal. So numbers that are smaller than 6 or less than 6 are not valid. So in this case, you would say your domain is all reals where x is greater than or equal to 6. Okay, so those are the two cases, the division by 0 and the even roots, that you have to worry about. You don't need to worry about odd roots. Odd roots, there is no restriction, because I can multiply odd number of times and retain my negative. So for any one of these sets, the domain is all reals. There is no restriction because they're odd roots. So the restriction's with the even roots and with division by 0. And with those two rules, you should be able to determine the domain of any function. Good luck.